Welcome to the virtual tour of the fabrication lab at the National Metrological Institute in Torino. In the Advanced Materials Division, micron and nano-patterning techniques are exploited to develop functional materials for a variety of applications. Several lithographical techniques are used to obtain different dimensions. Structures from millimeters to nanometer scale can be obtained by top-down method as optical, laser, and electron beam lithography. Our tour begins in the clean room, a lab having a special particle control to avoid the presence of dust. The characteristic yellow light is required for optical process. Let's start with top-down optical lithography based on the use of a resist deposited on a substrate. The photoresist is covered with a mask made of quartz and patterned with a chromium film blocking the radiation to the underlying photoresist. In this way, selected regions are exposed to UV radiation. Depending on resist type, the lithography ends up with a positive or negative process. As an example, a series of contacts for microprobe measurements. On the contrary to optical process, laser lithography is a sequential one in which a blue laser impresses the resist. The substrate is moved according to a CAD using a piezoelectric motors. Such a process allows to reduce the resolution down to 800 nanometers. Our tour continues in the Nano Facility Piemonte Lab, where two electron microscopes are available for nanofabrication. In particular, a dual beam electron microscope having both an electron and ion beam in the same chamber are used to pattern metallic film. The electron beam lithography is a sequential process as UV lithography and exploits a resist reticulating under an electron beam. The change of beam wavelength determines the resolution of the final nanostructure. Here we go as down as 100 nanometers. A couple of nanomanipulators in the chamber allows to perform in situ electrical measurements. Ion beam lithography, exploiting a 50-degree column, use gallium ion to directly remove the material according to a design card. We conclude our tour with nanosphere lithography, a bottom-up technique allowing to reach dimensional resolution down to 80 nanometers. Polystyrene nanospheres are commercially available in different dimensions. This is a rapid and expensive technique to pattern large film area. The process requires to deposit a single layer of polystyrene nanospheres on the film surface. This can be done in two ways. Deep floating is the first one and consists in the water dispersion of a nanosphere solution in ethanol. By adding a proper surfactant, the nanospheres are packed by the self-assembling process on the surface, and the monolayer is coated by dipping the substrate as shown. Another technique is by spinning a drop of nanospheres directly on the substrate, and the high speed allows the nanospheres to arrange as a monolayer. After the deposition of the monolayer on the substrate, the nanospheres are reduced by reactive etching. The magnetic materials among the spheres removed by physical etching. The deformed nanospheres are detached to end up with dotted structure. Freestanding nanodisk can also be obtained. By inverting the first two steps of the process, antidot arrays can be easily designed. This is the end of our tour through the exciting world of lithographic techniques. We sincerely hope you have enjoyed it, and more importantly, that you can get inspiration for your future research.